Question is asking, find the perimeter of the following figures. We have two figures. We have two figures. Even you can see. Yes, these are two figures. First is this and second is this. Each we have to find the perimeter of each this figure. Let's start from this figure. Only perimeter, not area. Okay, only perimeter. A. Area of this figure would be what? As we can observe, it is a semicircle. It is not a circle. Okay, it is not complete circle. It is just a half circle of a complete circle. So half circle is known as a semicircle. Now perimeter of a semicircle would be what? Perimeter of this would be what? First of all, as we know, perimeter of this complete circle is what? Pi r, 2 pi r, 2 pi r upon, here we have half, not complete. That's why we will divide. It means we are dividing. It will become two parts. Only we will have one part. And now, not plus this, we have to take this also, which measure is a 2.8 centimeter. Clear? Now here we know r would be what? R would be just half of this, which would be, I think, 2.8. So 2.8 half would be to 1.4, 1.4, or you can say 7 upon, no, 1.4. Yes. Now here 2 multiple 22 upon, so this 2 will cut, and 22 upon 7 multiple r is 14 upon 10 plus 2 28 upon 10. This is what we have. We can cut 7 2s and 2 5s. We have this 10 5. LCM of this 2 5s are 5 1s are 5. 5 2s are 10. 5 2s are 10. 5 2s are 10. Then 22 2s are 44. Plus 10 1s are 28 1. 2 2 4 to 6 7 upon 10. So finally we got this much centimeter. It is telling you perimeter of this plus this is how much? 7.2 centimeter. How much? 7.2 centimeter. So here we did what? Perimeter. To find out perimeter of this curve and this, we know that perimeter of this would be what? 2 pi r upon 2 because we have a half circle. And now we have to take this because this also we have to find perimeter of this. So we added this with this, and now after simplifying it, we got a perimeter of this from here to till here is 7.2 centimeter. 7.2 centimeter. centimeter. Now, perimeter of this figure. B. In this, we have a semicircle. We have a semicircle of radius of 1.4. So radius would be 1.4. Okay. What else? 1.5 centimeter, 2.8 centimeter. We have to find perimeter, not the area. So here perimeter would be this 1.5 plus 2.8 plus 1.5 plus 2 pi r plus 2 pi r, not 2 pi r, yes, 2 pi r upon 2, 2 pi r upon 2, this will cut, yes, no, 15 upon 10, 28 upon 10, 15 upon 10 plus 22 upon 7 multiple 14 upon 10, 7 to the 2 5 what else, 3 5 2 5 2 5 okay, 14 to the 5 to the 2 5 3 5 now here 3 upon 2 plus 14 upon 5 plus 3 upon 2 plus here 22 upon 5, we have this much, we have this much. Now what can we do, 2 comma 5 2 comma 5, here 2 ones are 5, so 10, LCM would be 10, 2 5s are 10, 5 3s are 15, 5 2s are 10, 28, 2 5s are 10, 3 5s are 15, 5 2s are 10, 22, was 44, 44, 10, 30, 40, 80, 80, okay, 80, 8 5, 13, 13, 5 9, 9, okay, 22, so 92, 92 upon 10, so finally we got 9.2 centimeter. This is what perimeter of from here to till here. 9 centimeter is the perimeter of B figure, of B figure. So not 9.2, it is telling you 80, 80 and this. What happened, brother? 80 and 20, 102. This is 102. That's right. 10.2. 10.2. This is complete answer. Now next question. Here we have applied a formula for perimeter of semicircle. Next, let's see what happens. What formula will we apply? We have this complete question. What is it asking? The shape of a garden. This shape of a garden is a rectangular. Is a rectangular. Angular, which means ends. Shape of end would be circular. So is a rectangle in the middle. In the middle, this is a rectangle, and a semicircle at the end. You can see this is a semicircle at the end of this rectangle. As you saw in the figure, find the area and perimeter of this garden. Of this garden. What? Area and perimeter. Area and perimeter. So let's start from perimeter. From perimeter. Perimeter of two semicircle would be what? 2 pi r upon 2. Yes, plus 2 pi r upon 2. You can say 2 times. Two times. Okay. Now what else? We will add this. From this and to this is how much? What is the measure of this side? If this is 1, this is 7. So of course we can say that radius would be 7 upon 2. 7 upon 2, or you can say 3.5. You can say 3.5. 3.5. So of course it would be 16.5. It would be 16.5. 16.5. So you can add 16.5 plus 16.5. 2 multiple 16.5. Clear? This 2 will cut. Okay. 2 pi r. 2 pi r plus 2 multiple upon 10. This will cut by 5. 5 3s are and 5 3s are. So we have 2 pi r plus 33. 2 multiple 22 upon 7. R is how much? R of this is 7. No, not 7. 7 upon 2 plus 33 upon 1. 7, 2. We have 22 plus 33, which is 5, 5. It is a perimeter. It is a perimeter of all this. 55 centimeter. Now hold on. I I got a 55, but should be 48. Should be 48. What happened? Here 5 threes are and 1 5 threes are okay. 33, 22, 7 ones are 2. 16.5. 16 point. So here it is as how much? 20. So of course I did wrong. What? Hold on. I did wrong here. This would be how much? 13. Because 7. This and this would be 7. 7 from 20. It will give us 13. 13 plus 13. Now 2 pi r plus 26. 2 multiple 22 upon 7. R is 7 upon 2. This and plus 26. 22 plus 26. 8 4 meter a square. This is a total perimeter of this garden. Now next. Next is what? Total area of this garden. Total area of this garden. Total area. So here we have two semicircles. We have two semicircles. So here pi r square, you can say pi r square. Pi r square. And now plus 2 multiple L multiple B. L multiple B. Now pi is 22 upon 7, R is 7 upon 2, 7 upon 2 plus 2 multiple, where is L? 30 multiple 7, 7, 11, 27 upon 2 plus 14, 13, 12, 1, 3, 4, 1, 4, 2, 8, 1. 182 upon 1, 2, 27, 2 ones are 2, okay, 182 multiple 2, 2 twos are 4, 2 8s are 16, 3, 364, 1, 13, 14, 4 upon 2, 2 twos are 4, 2 twos are 4, and here 0.5, 22.5 meter a square. I think it should be answered. So here I did draw what? Only L into V. Multiple 7, 1, 2, 9, 91, 2, 27 plus 91, 2s are 2 1s are 2, 9 2s are 18, 182. 1 5 15. Okay, 15. No, it is a 9 and 15 and 2. 2 ones are 2, 2 twos are 4, and 2 nines are 18.5. Hold on, 2 twos are 4. So 129.5 meter square is the area of this wall garden. Now here I was taking 2, but why? I will take only this and this. 13 multiple 7. That's it. Now next question. Next question is trapezium. Trapezium which means trapezium which means one pair of parallel lines and one pair of non-parallel lines. This is parallel lines and this is non-parallel lines. Here this is known as trapezium quadrilateral. Trapezium. Now area of trapezium. Trapezium. Let's say this is a 20 and this is a 30 meter. Here, look at this. Here, this is height. 12 meter is the height. 20 meter. This is 20 meter is the measure of this, and 30 meter is the measure of this side. And this is a height. Okay, this is height. So here, area of a trapezium would be just same here. You are observing what a triangle 1/2 multiple sum of parallel lines. Sum of parallel lines into height into height. Formula is this, just apply 1/2 sum of parallel lines, this and this. 20, 30, 50, multiple height is 12, 6 and 30, 300 meter square is the area of this trapezium. Just here you will observe a triangle, just 1/2 you write, and sum of parallel lines, not sum of non-parallel lines. Sum of parallel lines and then multiple height. So area of a trapezium would be 1/2 multiple sum of parallel lines multiple h b multiple h. So here, rather than taking this one, we are taking sum of this. First question based on this formula. This is complete question. Here this question. Uh, find find the area. You have to find area of trapezium. Trapezium. Okay. Just we saw formula for trapezium. Formula for trapezium is what? Find the area for trapezium whose parallel sides are 24 centimeter and 20 centimeter. Can we draw a figure of a trapezium whose sides of a parallel is a 20 centimeter and this is a 24 centimeter. So of course there is a trapezium. Trapezium looks like this. Now height is how much? And the distance between them, this distance between them is 15 centimeter. This is the height. A, B, C, D. D. Remember trapezium, definition of a trapezium, it is also a polygon, it is a quadrilateral, but it has a pair of parallels and a pair of non-parallels. Clear? Non-parallel lines. Yes. Now here, area of trapezium. Area of trapezium would be 1/2 sum of parallels. 2 plus 24 multiple 50. This much. 1/2 multiple 44. 44 multiple 15. 22. 22 multiple 15. 10. 11. 22. 0, 3, 3. 330 centimeter square is area of this trapezium. Is area of this trapezium. Clear? That's it. Just we applied formula to find out the area of a trapezium. We have given sum of parallels, measure of parallels, and we have given height. We have given height. Shall we take next question? Shall we take next question? This is what is a given question to you. The area of a trapezium is this much. Area is a given. Area of a trapezium is a given, which is area of trapezium is given, which is a 34 centimeter square. Length of one of the parallel side is 10 centimeter. Parallel sides. If this would be 10, then okay. C, D. and its height is 4 centimeter. This is 4 centimeter. This is 4 centimeter. Find the length of other parallel side. This we don't know this. Let's say this is x. Okay, this is x. Area of a trapezium, it becomes what? 1 upon 2 multiple x plus 10. Okay, multiple 4 is equal to 34. From this we will get x. X is a measure of this parallel side. Now 2 to the 4, as you know, 2x plus 20 is equal to 34. We have linear equation. 2x 34 minus 20, x 14 upon 2, 2 7 7. So x came as a 5, as a 7. So it means this is a 7, this is a 7, and this is a 10. Clear? If an area of a trapezium is given, then from here, and you had given what? This height, one side of one measure of one side of a parallel. Then you can find parallel one side length of other parallel side. So this is a length of other parallel side. So yes, x came as a 7 centimeter. Now next. Next is how to find area of general quadrilateral. Quadrilateral. Let's look like this. Here, if a quadrilateral is like that, there are not what equal. It can go like that. Yes, we have two diagonals. We have two diagonals. That's why we can get two heights of two triangles. Here, area of this would be area of A, B, C, D quadrilateral would be what? Would be what? So here we have two triangles A, D, B, B, C, D. Area of A, D, B. Triangle A, D, B plus area of DCB. Triangle DCB. Here, as you know, area of this would be what? 1 upon 2. 1 upon 2. B multiple H. So base is this. So here multiple BD uh, multiple h1 plus 1 upon 2 multiple bd multiple h2. Here 1 by 2 is common and bd is common. Now h1 plus h2, it's not common, so it is a formula of finding area of this type of a quadrilateral. Here this type of a quadrilateral. And area of rhombus, rhombus would be what? Rhombus looks like this. Here remember, rhombus quadrilateral will not have at the corner, at the vertex will not have 90-degree angle. Okay, except 90-degree angle it will have whatever, except 90-degree. And here there are two pairs of parallel lines. This is one parallel line, this is another parallel line. But angle at the vertex will not be making of 90 degree. So formula of this would be 1 by 2 multiple d into d2. d1 is a diagonal, d2 is another diagonal. Now next question. Next question is find the area enclosed by the given figure A, B, C, D, E, F as per dimensions. We have this computation. What is it saying? Find the area enclosed by given figure A, B, C, D, E, F as per dimensions given here with. We have to find the area of this and this. We have a combination of two shapes. One is a trapezium, second is a square. Second is a square. Here, area of this would be what? Area of trapezium. Trapezium would be 1 upon 2. Sum of parallel 6 and 20. 26. Height is 8 centimeter. 2 4 z. It is giving us 6 4 z 24. 2 4 2 z 8 2 10. This is a centimeter a square. This is area of this, isn't it? Now area of a square. Area of a square would be 12 multiple 12. 12 multiple 12. 400 centimeter a square. Total area would be 400 plus 104. 504 centimeter a square is the total area of this given figure. So answer is correct. Answer is correct. Next question I am going to write. Next question I am going to write. This is the total area of this. we have this complete figure of this equation. Question is asking. No, I know it took more time to write this. But it is a compulsory to write this as well. So, there is a boy. That boy has a square plot. As you can see, this is a square plot. So a boy has a square plot. In a square plot, he wants to construct. In a square plot, he wants to construct a house. Here. You can see in between. He wants to construct a house in the middle of the plot. A garden is developed around the house. So between house and this plot is a garden. Okay, let's say it's a garden. Find the total cost of developing a garden around. What will be cost of developing this garden, a garden around the house at the rate of rupees per meter square? It is clearly stating that you find what total area of this developing garden around the house. So it will be possible when we will have area of this square and area of this rectangle. This is not a square because this is a 15, this is a 20. Both are not the same. That's why this will be not considered as a square. Rather rectangle. Now area of a square. Area of a square would be 25 multiple 25. It will give us 625. I think so. Otherwise 25. 2 5 to the 10. Okay, 2 5 to 10. 2 to the 4 5. 5 to 6. Yes, it is correct. This is correct. Area of a square. Now area of a rectangle. Area of a rectangle is how much? 15 multiple 20. 15 to the 30. 1 more 0. It is a what? Meter a square area. This is area. This is area. Now we will subtract this from this. We will get area of this developing garden. So area of developing a garden. Area of a developing garden would be what? I think so. 625 minus 300. It is the area of a developing garden. 325 meter square. This is area of developing garden around the house. Now, what will be cost of developing of this area, of this garden area? So per meter is this much. When we will multiply this with this, we will come out cost. So here total cost of developing garden would be what? 325 multiple 55. From this we will find what total price of developing this garden around the house. Now here 325 multiple 5 5 5s are 2 and 12 1 16. Same here 2 6 1 5 7 8 7 1. This is a rupees. This is total rupees. 17,875 rupees. We will spend this much money to develop garden around the house. This much money. $300, yes. 325 multiple 55. Now next question. Next question is this is control question. This one is asking, you want to buy a trapezium shaped field. This shaped field you wanted to purchase. Its side along the river is parallel and twists the side along the road. Here you can see its side along the river. Along the river is a parallel. Is a what? Parallel. Okay, parallel and twists the side along the road. twist this side along the road. If I think this will be x, then this will be 2x, isn't it? Twist. If the area of this field is a 10,500 meter square, and the perpendicular distance between two parallel sides is how much? 100 meter. Find the length of the side along the river. So can I write x plus 2x? Yes, I can write. Here one figure we have trapezium figure. So formula would be 1 upon 2 multiple parallel sum of parallel lines multiple h. And height is how much? Height is 100 meter. Clear? Now area of a trapezium is given to you, which is 10,500 meter square. Now area of this 1 by 2 sum of parallel lines would be how much? X plus 2x. Now multiple height is 100 is equal to 10,500. 52 is 100. 52 is 100. This is 3x multiple 50. Now 10,500 upon 50. This and 5 2s are 5 10s are, isn't it? I think so. 5 2s are 5 2s are 10. 5 2s are 10. 5 1s are 0. 210. 210. X 210 upon 3. So x came as a 20. If this would be 20, this side, parallel side would be 20, then this would be 140. Clear? Now easily we can say one parallel side is 70. Second parallel side is 140. This is answer. Now next question. Next question is This is convert question. It is asking find the area of a rhombus. Area of this would be 1 upon 2 multiple d diagonal 1 and diagonal 2. This is the area of a rhombus. Diagonal this one, this is second. Rhombus whose sides are equal. Whose sides are equal is a rhombus polygon. Find the area of a rhombus whose side is a 5. Side is a 5 and whose altitude. Altitude is how much? This altitude is 4.8 centimeter. 4.8 centimeter. If one of its diagonal is 8 centimeter, this is 8 centimeter. Find the other diagonal. Find the other diagonal. Now here area of a rhombus. Area of a rhombus is how much? I think so now 1 upon 2. 1 upon 2 multiple d 2. It is how much? We have to find a second diagonal. It is a 5 multiple 4.8 centimeter. 4.8 centimeter. Now here 1 upon 2, one diagonal is how much? 8 centimeter. We don't know second diagonal. Yes, we don't know. 2 4s are 8. 5 multiple 48 upon 10. 5 2s are 10. 2 2s are 4. 4 2s are 8. 4 and 2 day 2. 24 upon 4 is equal to day 2. 4 6 are 24. So measure of a second diagonal is 6 centimeter. This is 6 centimeter. Clear? Here we found area of a rhombus. Area of a rhombus whose altitude is 4.8. So answer is correct.